Today, I will show you how simple it is to take into account censored data in Monolix. In the context of longitudinal continuous data, we talk about censored observations when we have measured something, but the value is either below the lower limit of quantification or above the upper limit of quantification. Although the exact value is unknown, the fact that the value is somewhere within an interval is informative. To take the information provided by censored observations into account in Monolix, the only thing the user has to do is to tag the BLQ data in the dataset. For this, we will use the censoring and limit column types. Let's see the different possible situations. For a normal data point, I would have the ID, the time of the measured value, and a 0 in the censoring column, meaning that the data is not censored. If the data is below the lower limit of quantification, I tag it with a 1 in the censoring column and I put the LOQ value in the observation column. This line here means that my observation at time 1 is between -infinity and 0.1, the LOQ value. In case of concentrations, we also know that the measured value is positive. In that case, we can use the limit column to indicate the other bound of the interval. This third line here means that at time 2, I have measured something between 0 and 0.1. If you don't want to indicate the other bound, just leave the limit column out, it is optional. It can also happen that the value is above the upper limit of quantification, in particular for PD data. The logic in that case is the same, except that the tag in the censoring column will be -1 instead of 1. Here too, the interval can be up to infinity or have an upper bound. So a typical PK dataset with censored data would look like that. In this example, all individuals and all times have the same LOQ value, but the LOQ value could be different for each line. Once the censored data are tagged in the dataset, they will be taken into account by Monolix automatically and in the right statistical way for all estimation tasks. Instead of writing the probability of having observed the value exactly, as in the first line here, when the data is censored, we write the probability that the observation is within an interval, and this can be rewritten as an integral. If you are familiar with the non-mem M methods, this corresponds to the M3, M4 methods. Now let's see how the BLQ data are displayed in the plots. I have opened the Censoring1 project from the demos. In the dataset, I have both a censoring column and a limit column, and we see here that the LOQ value is 1.8. In the plots, if I look into the individual fits, I see that the BLQ data is represented by a pale red rectangle to indicate the censoring interval. In the ops versus spread plot, the censored data is also displayed in red. For the observation axis, we need a precise value. We could use the LOQ value. It would look like this, but this would not be very informative. So instead, we use simulated BLQ values. The simulated BLQ are generated by adding the residual error on top of the individual prediction using a truncated normal distribution to make sure that the simulated BLQ remains within the censored interval. The same is done for the residuals. If we do not display the residuals calculated with the simulated BLQ, one could think that there is a tendency in the residuals. But if we display the residuals using the simulated BLQ, we see that in fact there is no tendency. We also use simulated BLQ for the VPC. As for all other plots, using the simulated BLQ permits to use all the available information and avoid spurious bias. If you don't want to use the simulated BLQ, you can go to Display and untick Censored Data and also untick Use Censored Data. And finally, when censored data is present in the dataset, a BLQ predictive check is available. The dark blue line represents the proportion of BLQ data in the original dataset between time 0 and time t, and the blue 90% prediction interval is calculated using simulated datasets. In summary, the only thing the user has to do to use censored data in Monolix is to tag them properly in the dataset. And then Monolix automatically uses the censored data information for all estimation tasks in the right statistical way. And finally, in the plots, the simulated BLQ values allow to diagnose the model efficiently. If you want more examples about how to use censored data in Monolix, check our online documentation. See you next week!